All right, so let's remember that last night we looked at solving systems by graphing, where I wanted to find the point of intersection, and that point was a set of coordinates. It had an x value, and it had a y value, and that this pair of coordinates was my solution to my system of equations, where I have two or more linear equations. Remember, this is for linear equations only. Okay, so if I'm solving these systems of equations by graphing, then I need to have a clear intersection point. Let's zoom in here and look at this. If I look at this graph, I can't accurately pinpoint where this intersects my y or where it accurately intersects my x. I don't know exactly. I can ballpark it, which is good with word problems or real-life scenarios generally, but if I need to be really specific to find the solution to this system, I'm going to have to find it a different way. So there's another way to solve a system of equations. Having a graphing calculator is super handy. It'll tell you where the points intersect. Let's say your graphing calculator's batteries have died, or you're on a standardized test where you're not supposed to use one. How on earth can you solve this? Well, let's think about this for a second. If I know that I have a y equals up here, and I have y equals down here, is it true then that if it's a pair of solutions that my y equals my y? Well, logically it should be. So let's rearrange this equation and turn it into 1, and we're going to use substitution. All right, so now what I'm going to end up doing is plugging in my equations for my values. If I know that my y equals my y, because they share this point in common that was a solution to both of these systems, then I can substitute my pink y over here and set it equal to my blue y, because there is some point on a graph where they share a y value. That's their solution. So I'm trying to find their solution by setting the formulas equal to each other. So I know that if I know that pink y equals blue y at some point, then I can substitute in this guy for my pink y. And I can substitute in this formula, because it's equal to y, over here on this side, and I can make them equal. So let's see what that looks like. Make sure you're writing this down with me. So I get x plus 6.1 equals negative 2x minus 1.4. Okay, now remember how we solved multi-step equations? I need to identify my variable and my constant. Variable and constant. And I'm going to get them all on the same side. So I like to keep my x's on the left. So I'm going to end up doing the opposite here. So it's a positive 2x because I've got a negative in my circle. And I've got to add it to both sides. All right, so what I get is 2 plus 1 is 3x. I still have the 6.1 I've just got to bring down. Remember that this is a constant. Equals, these cancel out, and I'm left with negative 1.4, also a constant. I want to get all my constants on the same side, though. So which one do I want to move? Do I want to move my blue or my pink? Well, if I move my blue, I'm going to end up with 0 on this side, and I don't want that. So instead of doing that, let's move my pink over here. So we're going to subtract 6.1 and subtract 6.1. What do I get? Bring my 3x down, set everything equal, these cancel out. I'm going to do 4 plus 1 is 5, 1 plus 6 is 7, and remember my sign is negative. All right, it's not the prettiest number, but it's not impossible. I'm not done yet. I still have to get x by itself, so I need to divide both sides by 3. If I'm dividing both sides by 3, then x equals whatever this is. All right, plug this into your calculator. Good, hopefully you got this. Okay, remember this is the x value for where my lines intersect. So this is telling me it's going to intersect up here at 2.5. So I'm going to come up here and I'm going to write that in for my x solution. And if this is my x solution, then I need to plug my x value here. It's negative. Don't forget to write your negative. I need to plug it in for one of my x's. It can go in my blue or it can go in my pink. It doesn't really matter, but now I end up having to plug it all in. So your first step was to set your y's equal. My second step was to solve for x. And my third step is to plug x in and solve for y. And you'll see this third step here. It doesn't matter which one. Let's do it both ways. If I do my pink, y equals, and I'm going to plug my x in, negative 2.5 plus 6.1. That's this formula right here. In place of x, I put negative 2.5. So now I'm going to solve for y. Y equals, well, what is 6.1 minus 2.5? Plug it into your calculator. 6.1 minus 2.5 is going to be a positive 3.6. Again, not a pretty number, but it works. Now let's see that we get the same thing if we go with our blue formula instead. So if I use the formula y equals negative 2x minus 1.4, and I'm going to plug my x over here in, then y equals negative 2 times what? Good, negative 2.5. And then to that, I'm subtracting negative 1.4. Do your math. Remember, this is technically negative to the quantity. So negative 2 times a negative 2.5 is going to give me something that's a positive. Plug it into your calculators. This is going to give me a positive 5 minus 1.4. Plug it in. At this point, I get 3.6. Look at that. It's the exact same number because these solutions, these systems are equal. They equal each other both at the same x and the same y. So now if I go back to this graph that I had earlier, what this is telling me is that this point that I highlighted and couldn't quite nail down over here is this point right here. It is negative 2.5 with a y value of about 3.6. Now I always want to check, and the way that I check my work, so let's come back over here and look at all this mess. We're going to add our fifth step. Our fifth step is to check our work. When we check our work, I want to go back to this concept right up here where I had y equals y. So I have x plus 6.1 equal to negative 2x minus 1.4. This should all be in blue. Now I'm going to plug in my x value for negative 2.5. And I want to see if these equal. So then over here, I'm going to end up with negative 2x. X is negative 2.5 minus 1.4. And I want to see, is this equal? So negative 2.5 plus 6 plus 1. What is this? Well, hopefully you got 3.6. And I want to see, is this equal to over here? Negative 2 times negative 2.5 is what? Good, positive 5. And 5 minus 1.4 is 3.6. So this tells me that my x point matches. Woohoo! Now I want to make sure that my y matches. Well, we've already kind of done that because I've plugged my x into both of these, and it is true. The other way you can check is to go back to, let's take x plus 1. And this equals y, right? Okay, well, I want to plug my negative 2 point. I'm going to check my y by plugging in one of my variables here. Let's do 3.6. and I want to see, does this equal 6.1 plus negative 2.5? I'm asking myself if these two things match. Well, if I plug in 6.1 minus 2.5, I should get 3.6 equals 3.6. So this tells me my x checks out, and down here this tells me my y checks out. Yes, my math was good. My solution, remember, is always an ordered pair, so you're going to get 2 points here. All right, so now on your own, I'd like you to go back and I'd like you to set these up as equal, solve for x, plug x in, solve for y, and check your work. Make sure to show me your work, make sure to check yourself, and I'd like you to solve this system of equations. Notice in this guy, you got to be careful. You're going to end up having to do something special to it.